Hello everyone, welcome to Circuit Bits. This is the first video in a series about PIC microcontrollers. And this is also my first video here on YouTube, so go right ahead and tell me how much this video sucks in the comment section below. In these videos, I will take you through the learning process step by step, and I will show you how you can get started and how you can design and build your own projects. Here are some of the microcontroller examples that I've already built. This is a 3D LED cube. It's very fancy, blinky, and you can impress your friends with it. Or maybe you're interested in building a robot. Well, here is one of the driving robots. Or maybe you're interested in building a multimedia application. Well, this will do it. Or maybe you're just interested in conquering the world with your robots. Well, you can do that too. Well, whatever the reason might be, I'm here to help. By the way, this is a clock I built a while back. See if you can tell when I recorded this video. And yes, there might be a bit of math and a lot of programming.
You will not laugh. You will not cry. You will learn by the numbers. I will teach you.
Alright. But before we begin, does anyone know what microcontrollers actually are? Alright, so in this video, I'll try to go through all the boring stuff so we can get to the juicy stuff in the next video. And by juicy stuff, I mean we'll get to actually program one of these suckers. Let's get started. Microcontrollers are programmable integrated circuits, or ICs for short, or simply chips. They can perform many different tasks, but usually they are used to do one specific thing. Essentially, it is a mini computer on a single chip. In fact, let's compare a microcontroller to a computer. I will use this table to show you how similar they actually are. First up is ROM, or read-only memory. The first thing that comes to mind when talking about computer ROM is BIOS. For microcontrollers nowadays, ROM comes in the form of flash memory. This is where the program that runs on the microcontroller is stored. Since it is a flash memory, you can rewrite or erase the program stored on it. Next up is RAM, or random access memory. This is where all the running programs and data that is being used are stored in a computer. Microcontrollers use RAM as well, and it is used for exactly the same purpose, except that only one program is using this memory and there is much less of it. In both cases, if you remove power, data stored in RAM will be lost. For a computer, storage device is usually a hard drive or an SSD. This is where all the data is stored and it remains there even if a computer has no power. This type of data storage is usually much slower than RAM. Microcontrollers usually have a storage device called EEPROM. This is also much slower than RAM. Data stored here will remain there even if you remove power from a microcontroller. This could be used to store user settings, configurations, sensor data, or any other data which needs to be available after a reboot or power cycle. Peripherals for a computer are the means to communicate with the outside world, such as monitors, keyboards, USB ports, and so on. Microcontrollers also have peripheral components that are located on the same chip. For example, all of them have I/O pins or input-output pins. Many have other peripherals such as I2C, SPI, USB, or serial interfaces. We will cover these in a later video. When it comes to operating system, this is where similarities end. Computers run multiple tasks at the same time, and therefore an operating system is required to manage and allocate computer resources. On the other hand, microcontrollers usually run a single program which has direct access to the hardware, and so operating system is not necessary. In our everyday life, we are surrounded by microcontrollers. Think of any electronic gadget and most likely there is a microcontroller inside. Your TV has one, as well as its remote. Cameras also have microcontrollers. Microarrays, washing machines, cars have tons of microcontrollers in them. Keyboards, mice, webcams, printers, flash drives. The list just keeps getting bigger and bigger. Look, all I'm trying to say here is that they are everywhere. In front of me, I have just a few examples of microcontrollers. At the very bottom you see a variety of bare chips. all of the microcontrollers in the bottom row are examples of 8-bit PIC microcontrollers. The 3 microcontrollers on the left are examples of DIP package. This was the oldest available package. We will be using it a lot as it is useful for prototyping because the pins are easily accessible and they fit nicely into something called breadboard, which we will talk about later. The disadvantage of these packages is that they are very big, and in general you want your device to be as small as possible. Therefore, nowadays these are not used for finished products. This brings us to the next package, which is SOIC. They are smaller than DIP ones, but it is still relatively easy to manually solder them, which allows us to create smaller finished products. The next microcontroller is in QFP package. It is similar to SOIC, but the leads are located on all 4 sides. This allows for higher pin density, but this also makes it harder to solder. The final package on the bottom row is QFN. This one is very difficult to work with, but if you are skilled enough with the soldering iron, you can end up with a very small board. In the middle row, I've placed more PIC microcontrollers, but here they are 32-bit versions. As you can see, they come in the same packages as their 8-bit counterparts, DIP, SOIC, QFP. You can see that QFP is actually soldered onto a board, which is called a breakout board. This makes it much easier to access the pins while prototyping. In the top row, there are a few examples of other microcontrollers. As you can see, all of them come in their own boards that contain some supporting components like oscillators, capacitors, and switches. The 2 microcontrollers on the left are actually the same, they just come in different breakout boards. And finally, this one is the famous Arduino. I'm sure many of you have heard about it. There is a lot of information online about this board. There are many more different types and packages that microcontrollers come in. But in the next video, we will concentrate on PIC microcontrollers, and we will also write our first program. I hope you guys enjoyed this introduction video. Leave your comments down below and stay tuned for the next video.